Run through the fourth review sheet, which is basically a concavity practice. So let's take a look at this. I also have an extra review question thrown in at the end. It says, given the chart below, determine whether g of x is increasing or decreasing, and what is its concavity. All right, so let's take a look at this. Anytime it asks about increasing or decreasing or concavity, we're going to use average rate of change, which is basically the slope, right? And I always suggest doing at least 3 of them so that we can compare all the different values. So let's take a look at this. So I'm going to do change in y over change in x, so negative 3.1 minus negative 5.7 all over 2.4 minus 1.5, right? So we got a double negative here, so that's going to be approximately 2.6 over, this would be 0.9. All right, so this is going to be approximately, now if you do that in your calculator, it's going to be approximately 2.8 repeating. Right? So let's do the next one, negative 1.4 minus negative 3.1. Now again, your final is written so that you don't need a calculator at all. So I promise that when you go to do this on your final, every single one of these is going to be easy to do. I mean, obviously I'm not there. You could use a calculator. But remember, you should be giving me no decimals as answers on that exam, because everything actually comes up to be pretty numbers. Or you leave it kind of like in the last one of those other review assignments, you leave it in like log form or whatever. This was 0.8. Let's see here. And this one came out to be 1.16 repeating. All right, so I do at least 3 average rate of changes. And then I look at these. Are these positive or are these negative? Okay, these are positive. So since the average rate of change are positive, g of x is increasing. So whether it's increasing or decreasing depends on whether this is positive or whether this is negative. Since they're all positive, it's increasing. It'll never, at this level, be a mix of the two. Now, look at the value of these. What is happening to these numbers? These numbers are getting smaller. So since the value of the average rate of change are decreasing, g of x is concave down. So positive or negative means either increasing or decreasing. What the numbers are doing tells me the concavity. All right, so let's take a look at number 2. Given the chart below, determine if it's, okay, same deal, average rate of change. So I'm going to do 0 minus negative 5 over 4 minus 1. That's 5 over 3, which I prefer way more than a decimal, so I'm leaving that. Then I'm going to do 10 minus 0 over 10 minus 4, which is 10 over 6, which reduces to be 5/3. And 15 minus 10 over 13 minus 10. Makes 5/3. All right, now first off, they're all positive. So since the average rate of change are positive, h of x is increasing. Right? So it's increasing. And since the average rate of change are constant, they're all the same, there's no concavity. So this one has no concavity, and that's because it's linear. Anytime the average rate of change stays consistent, it means actually slope, and that means it's a line, and lines do not have concavity. All right, so that was the first page. Then on the second page, We had to sketch this. I don't know if you remember, you guys, this was literally like an assignment you guys did a few months ago. You want to graph this guy. Sketch the graph of f. So here we go. It has zeros at -1 and 4. So that means we have to hit the x-axis at -1. 1, 2, 3, 4, and at 4. Okay? F at 0 needs to be at -3. So 1, 2, 3. That's -3. F at -4. 2, 3, 4, -4. It needs to be at 3. 3. So -4 is at 3. All right, so that's what I've got so far. Now, F is decreasing concave up, coming from -infinity towards -4. So it's got to be coming down and concave up. So it's going to look something like that, right? It's decreasing concave up. Then it needs to be decreasing concave down from -4 until we get to 0. And notice we have to hit there. So I'm going to come down. It's going to kind of hit there. F is increasing concave up from 0 to 4. So like that. And increasing concave. Boom. Great. And that is what the picture should have looked like. All right. This is like the one at the bottom part here is what you're supposed to have done before. So increasing, decreasing, concave up, concave down. So this is 20 minus 0, 1 minus 0. That's 20 over 1. 35 minus 20 over 2 minus 1. So that's 15 over 1. And I usually just do one more to make sure I didn't make a stupid subtraction mistake or something. All right. They're all positive. So because they're all positive, it's increasing. And notice, look at the numbers. The numbers are getting smaller, so it's concave down. Okay, next one. You do 10 minus 20 over 1 minus 0. That's -10 over 1. 6 minus 10 over 2 minus 1. So it's -4 over 1. And then 3 minus 6 over 3 minus 2. So it's -3 over 1. All right, notice they're all negative. So that means this one is decreasing. Okay. Now let's look at the numbers themselves. All right, what's happening to these numbers? -10, -4, -3. So what's the value of those numbers? The value is getting bigger, so it's concave up. Okay. And then the last one, I don't know if you guys noticed, it's the same exact thing as the first one on the front. So I'm not going to redo it. It's just the same exact thing. So there you go. So that was worksheet number 4 on concavity. And if you talk about concavity, you're doing average rate of change. Again, if the numbers are all positive, it's increasing. If the numbers are all negative, it's decreasing. And if the value of the numbers is increasing, it's concave up. And if the value of the numbers is decreasing, it's concave down. And if those numbers aren't changing at all, there's no concavity. All right? So it's a nice little synopsis. But while I have you here, I would love for you to try this question. Okay. A sheep herder wants to build a rectangular fence to enclose his sheep up against a river. He has 2,000 feet of fencing available. What should the dimensions of his pen be if he wants to maximize the area? All right, now let's talk about what the scenario is talking about. So we have a river, right? That's our river. And he wants to build a pen, a rectangular one, up against the river. Now, what's interesting about this, guys, is sheep will not go in the water. You don't want to die. So anytime there's something here, you don't have to run fencing against it. It's unnecessary. So we only need these 3 sides to use to build the fence. So we want to maximize the area of this. All right, so we have 2 different dimensions, x and y. right? And we want to maximize the area. So the area, actually I'll do this here. The area of this thing would be x times variables. We did a similar question to this in packet number 1. Is there something we haven't used in this story? I think you noticed the 2,000 feet of fencing, right? We're going to use that to help us out with our area. Well, if you know this is x, then this has to be x. And again, we don't need any more here because there's already something there to barricade it, the river. We don't have to go there. So that means we have 2 x's plus y worth of 2,000 feet of fencing. Well, if you notice here, we want to get an area formula with just x's in it. So we're going to use this to help us. Because looking at this now, I know that y would be equal to 2,000 minus 2x. So I can come up here now and build an area formula, a of x, where I can replace y now with this. Okay, so now, what should the dimensions of this pen be if we want to maximize the area? Let's see if you can figure that out. Yeah, I figured the beginning is usually tough to get going, but from here maybe you can finish it. So pause me, see if you can do it. Okay, so I hope you pause me for a second to see if you could finish it. What I was hoping you guys noticed is that this was 2,000x minus 2x squared, right? Which would make it a sad face parabola. So the maximum right there, right, we could get by using the axis of symmetry, which should be on your formula sheet, which is x equals negative b over 2a. All right, so we're going to plug into this. So x equals negative, the b would be 2,000, over 2 times a would be negative 2. And that would be, what, 500? All right, so guys, that's the x value that would maximize the area. So my first dimension would be 500, right? How would I find the other dimension now? We'll plug 500 into this, right? So if I do y equals 2,000 minus 2 times 500, which would be 1,000. All right. So the dimensions to maximize would be a 500 foot by 1,000 feet. That should be the dimensions you should build to maximize the area. So your goal here is to always get an area formula in terms of x by substituting in. All right. So you guys now have packet number 5 you should start working on. You should also start organizing your formula sheets, right? I was looking through it. These are the ones we've done so far: exponential functions, power functions, converting from radians to degrees, degree to radians, converting polar coordinates to Cartesian, right? Compound. Oh, you know what we should put on here if it's not compound? Continuously. There's 2 other formulas. There's just percent increase / decrease. And that basic formula is what? A of, all right, and K is what was the every. So if they said something happened every 5 years or every 2 days, you plug that number in there. And then there was just the basic compound interest, right? Which would be A of t equals A sub 0, 1, plus, it's just plus because interest is always adding, R over N to the NT, right? And N equals how many times compounding. Right, so if it said monthly, you would use 12. Hourly, you would use 24, depending on the wording of the question. Yearly, 1. So let's look at this sheet again. So exponential function, power function, converting from polar to Cartesian, and then the interest ones, right? Then we also had all the trig stuff, axis of symmetry, the unit circle, pi over 3 is 60, right? You should have written these down while we were going through the other review packets. Inverse trig and the restrictions. Right. Then all the double angle formulas, the sum and difference formulas, how sine and cosine left period. I think that was everything at that point. And that is it. All right, so you should get these formulas, like I said, set up for yourself. Maybe write them over neatly so you have them all in one place. Here, if I pull up, kind of show you what we've done so far. And we have more packets to go through, so if you see other things, so if you want to pause this and take a look at it, organize it maybe better in a way that you might like. So that's one of the sheets. And there's this sheet. And then this one with the formulas for the trig. Right. And I think these sheets contain them all. Basically, review packets 1, 2, 3, 4, right? We already kind of have it all covered. I don't think I've missed any formulas. And then, like I said, we'll go through a few more and